Now we'll be turning to returns to scale. This concept refers to the change in the amount of output in response to a proportional increase in all the inputs. So I discussed this previously in the long run production video. So we're looking at how does output change when both labor and capital double or triple or increase by 1.5, right? So that's what this returns to scale is looking at, what it's asking about. There are three types of returns to scale that a production function may have. So first is constant returns to scale. So if we say double capital and labor, that means that output should also double, right? Most Cobb-Douglas production functions exhibit constant returns to scale, and we can see that in a shortcut way by looking at the exponents. If those exponents sum to 1, then we have constant returns to scale. So if we have quantity of output equal to capital to the alpha times labor to the beta, right? If alpha plus beta equals 1, that means that we have constant returns to scale. If output plus beta is greater than 1, then that means we have increasing returns to scale. So increasing returns to scale is when we double capital and labor and get more than double output, all right? And then lastly, if alpha plus beta is less than 1, that means that we have decreasing returns to scale, which just means that if we say double capital and labor, we get less than double output. Okay. So we're going to look at these each in more detail. So here you can see them graphically. As inputs double for constant returns to scale, we get a doubling of output. For increasing, as inputs double, we get a more than doubling of output. So from 1 to 2.5, as we double capital and labor from 1 to 2, and from 2.5 to 6, as we double capital and labor from 2 to 4. And then for decreasing returns to scale, as we double inputs, we get less than double output. So as we double capital and labor from 1 to 2, we get output increasing from 1 to 1.8 rather than to 2. And as we double capital and labor from 2 to 4, we get output increasing from 1.8 to only 3, right? So again, we don't get that doubling happening. So looking at an example for constant returns to scale, if we have a production function of output equal to k to the 1/2 power times labor to the 1/2 power, and we start with each input equal to 1, then we get a output of 1, right? 1 to the 1/2 power is just 1. 1 times 1 is 1, right? If we now double capital and labor, right, we have the square root of 2 multiplied by a square root of 2, so that gives us an output of 2, right? And then if we double capital and labor again to 4, we get the square root of 4 times the square root of 4, which gives us a doubling of output to 4, right? So when inputs double, output doubles, right? Let's look at and one thing here, we can tell that our production function has constant returns to scale by looking at the exponents, right? So 1/2 plus 1/2 equals 1. So that tells us that our production function has constant returns to scale. Moving to a new production function here, we have k to the 1 power times L to the 1 power. This is going to show us increasing returns to scale. We can see that very quickly because 1 plus 1, those exponents on our variables, when added together equal 2, which is greater than 1. And so we should expect output to more than double, right? So if we start with each capital and labor equal to 1, we have 1 times 1. That gives us 1 unit of output. If we double capital and labor from 1 to 2, now we get 2 times 2, which gives us 4. So output has more than doubled, and you can see that quite clearly. If we double the inputs again, so each is equal to 4, now we get output of 16. So again, more than doubling output as we double those inputs. Why might we have increasing returns to scale? It's not going to be very common, but it happens sometimes. Constant returns to scale is most often what we see in the world, especially with firms that survive over time. So when might this happen? First and foremost, due to a firm having high fixed costs. So let's say you start a new business, you're getting it started before you even have a single sale. You might set up a website and hire some management for that, as well as set up some advertising. So that's before you even sell anything. So those are your fixed costs. And so if those fixed costs are quite high, what you might see happen is as you double your capital and labor, you're not going to also double your advertising or double your web page. So what you're going to end up seeing is that your output will double without all of your inputs doubling. So that's going to give you that increasing returns to scale. We might also see this with learning by doing, where a firm develops more efficient processes as it expands or produces more. You experience this probably over the semester as you get to learn a new faculty member, learn what they expect from assignments, how to do certain skills, right? You get more efficient with it. So as a firm produces, as its workers produce, they learn how to do things more efficiently, and thus you get more output from the same number of inputs. So this looks like in the aggregated data, increasing returns to scale. Lastly, we're going to look at decreasing returns to scale. We can see that our new production function here has decreasing returns to scale by looking at the sum of those exponents. So 0.5 times times 0.25 is going to give us 0.75, which is less than 1. So we're going to have decreasing returns to scale. So let's see if we do. So if we have quantity equal to k to the 1/2 times L to the 0.25, and we have 1 unit of each, we'll have 1 times 1, so that gives us 1 unit of output. If we double capital and labor, we'll have 2 to the 1/2 power times 2 to the 1/4 power. That's going to get us 1.68, right? So we've doubled capital and labor, but output has less than doubled. And then if we double our inputs again, we'll have 4 to the 1/2 power times 4 to the 1/4 power, and that is going to give us 2.83. And again, we see that output less than doubles. Decreasing returns generally we don't see, especially in the long run. So firms shouldn't experience this because it's not efficient, right? They're going to be outcompeted and leave the market. So often we're only going to see decreasing returns in the short run, and it's often resulting from some data error. Like we haven't accounted for all inputs or attributes of the firm, and that's why our data is showing us decreasing returns to scale. We might also see that there's some existing efficiencies that haven't been rooted out yet, and if they don't get rooted out, then the firm shuts down in the long run. All right, so quick practice problem for returns to scale. Given a Cobb-Douglas production function of quantity of output equal to k to the 0.75 power times L to the 1/2 power, what types of returns to scale does this firm have? So we can use our sort of quick check by seeing what the sum of the exponents are. So we have 3/4 plus 1/2. Right? That is going to give us 1.25, which exceeds 1. So that means that we think this Douglas production function has increasing returns to scale, and that is the case. So we're going to leave this here and move on to technological change in the next video.